This video will show you how to perform a two-sample t-test in R. I'm going to use the iris dataset to explain and walk through this example t-test. So I'm first going to read in the iris dataset. Then I'm going to print the iris dataset to my screen. And so the dataset I'm looking at has three different species of iris flowers, along with some basic measurements of those flowers: the sepal length, sepal width, petal length, and petal width. So we can see we have the data here. Now I'm only interested in, for this hypothesis test, in the setosa measurements and the versicolor measurements. So those are two different species that are a part of the iris dataset. So I'm going to use a subset function to basically get each of those species into their own data frame. So I'm going to name the first one setosa, and I'm going to find only the setosa measurements from the larger iris dataset. And then the same thing for versicolor, only the versicolor species measurements from the larger iris dataset. So I click run to run that, and you can see in the upper right I have 50 observations in setosa, 50 observations in versicolor. And so my task here is I want to perform a two-sided, two-sample t-test at a level of significance of 0.10. That's also called our alpha. My null hypothesis is that petal width for setosa flowers is equal to petal width for versicolor flowers, and the alternative hypothesis is that they are not equal. And so I want to run through this test and interpret the results, i.e., would I fail to reject or reject the null hypothesis. To do this, we're going to use the t.test function, which allows us to perform different kinds of t-tests in R. The two variables I want to test are the petal width from the setosa dataset, that contains all of my measurements on the setosa flowers, and the petal width measurements from the versicolor datasets. So that's my hypothesis test, is comparing these two different species and whether or not the petal widths differ. For the alternative statement, I'm going to say that I'm doing a two-sided t-test. And so in this case, in the two-sided two-sample t-tests, we're really comparing the difference. That is, if we found a difference between the petal width and in the setosa dataset and the petal widths in the versicolor dataset, then that would be an indication that our hypothesis would be rejected, or we would fail to reject. And so in this case, I'm doing a two-sided. For my confidence level, I can change the value that the confidence level provides. And so in this case, I want to do a 0.90 or 90% confidence level, and that will roughly align with my level of alpha of 0.10. And then I'm going to say that the variance is not equal. So I'm going to do var.equal equals false. And depending on whether you put false or true in this statement, you may get slightly different answers, in particular for the confidence interval. And so I'm going to run this chunk of code, and let's take a look at the output. And so it says it's done a Welch two-sample t-test. The data sets it used were petal width from setosa and petal width from versicolor. It calculates a t-statistic of negative 34.08. It calculates a number of degrees of freedom, and then it gives me a p-value. And so the t-statistic we could calculate by hand if we wanted to, but we know that t-statistic is very high, so we're going to get a very, very small p-value. And in this case, this is 2.2 times 10 to the negative 16th power, a very, very small value. So then it says our alternative hypothesis is that the true difference in means is not equal to 0, and it provides me the 90% confidence interval. And so this interval would be between the difference, that is petal width from the setosa dataset minus petal width from the versicolor dataset. So the average difference is somewhere between negative 1.13 and negative 1.02. And then the last thing it does is it provides the mean of x. So this would be the mean of the petal widths from setosa and the mean of y, or the mean of the petal widths from the versicolor data set. And so how might we interpret this, this output? So we can say that because the p-value of less than 2.2 times 10 to the negative 16th is less than the level of significance, or our alpha level of 0.10, we can reject the null hypothesis and conclude that the population mean for Setosa petal widths and versicolor petal widths are not equal. And so that's how we can write and perform a two-sample t-test in R.